Good afternoon, all. Myself, Milind Kansara, lab in charge of Tinkering Laboratory. Today, we have special guest Dr. Siddharth Joshi, Professor Ravindra Desai from Electrical Department, RNGPIT College, and Head of the Electrical Engineering Department, Professor Chinmay Desai. Okay. I request Ravindra sir to give the information about the Siddharth sir, as well as I request Chinmay sir to say about the session. First of all, I request Chinmay sir.
Good afternoon, everyone. આજે આપણે જે સેશન અરેન્જ કરવા જઈ રહ્યા છે એ સોલાર ફોટોવોલ્ટિક અને ઇન્સ્ટોલેશન અને ડિઝાઇન અને ગ્રીડ સાથે કઈ રીતે આપણે થાય એના વિશે આપણી પાસે ઘણા સારા આપણા એક્સપર્ટ સિદ્ધાર્થ સર છે, જેમને 12 વર્ષથી લગભગ રિન્યુએબલની અંદર કામ કરવાનો અનુભવ છે. પીડીપીયુમાં એઓ પ્રોફેસર છે અને એમના અનુભવનો લાભ, જ્ઞાન અને અનુભવનો લાભ આપણને આવતા કલાક દરમિયાન મળતો રહેશે. સાથે બીજું એક આજથી આપણે દરેકને એક ઇન્ફોર્મેશન મારે શેર કરવાની છે કે જેવી પાર્ટિસિપેટ કરશે એને આપણે ઈ સર્ટિફિકેટ આપણે આપવાના છે. એના માટે તમારે આખું સેશન થોડું આખું ધ્યાનથી એટેન્ટિવલી પ્રેઝન્ટ થઈને કરવું પડશે અને એન્ડ ઓફ ધ સેશન તમને પાછી એના પર લિંક શેર કરશું. એની ઉપર જે ક્વિઝ છે, સ્મોલ અને ઇઝી એકદમ ક્વિઝ હશે, સેશનને લગતા ક્વેશ્ચન છે એ અને ફીડબેક તમારે જમા કરાવવાનો છે. તો એના પરથી તમને ઈ સર્ટિફિકેટ જે છે એ તમારા મેઇલ પર તમને મળી જશે. તો સરને હું રિક્વેસ્ટ કરીશ કે સેશન સ્ટાર્ટ કરે એ પહેલા રવિન્દ્ર સર વિશે જરાક ઇન્ટ્રોડક્શન તમે આપી દેજો.
Good afternoon, one and all. I, Ravindra Desai, Assistant Professor in Electrical Engineering Department, RNGPIT College, Bardoli, welcomes you all. Today, we arrange webinar on solar photovoltaic system, its design and grid integration. For that, today we have an expert, Dr. Siddharth Joshi sir, Assistant Professor in Electrical Engineering Department, PDPU, Gandhinagar. Sir, we are welcoming you all on behalf of the RNGPIT family. Before we start, let me give brief introductions about our expert, Dr. Siddharth sir. Sir has completed his PhD in electrical engineering from RK University. Sir having more than 12 years experience. He has published 33 research papers in national and international conference and journal on renewable energy. Sir is lifetime member in IETE and also member of IEEE. Sir guided several MTech theses and delivered lectures on renewable energy like solar and wind energy, its integration, standalone system, and hybrid system also. So now, sir, over to you. Share your great experience with us. Thank you.
Okay, thank you, sir, for your kind introduction. Good afternoon to one and all. Our today's topic is on design and grid integration of solar photovoltaic system. Let me begin with one simple thought. When I got a call from the institute, at that time, they shared one experience with me that student must know how to design a simple rooftop system for residential application and how we can integrate this rooftop system that is connected with the grid. So this entire session is basically focusing on design and grid integration as a whole. But any source, if you can take an example of solar or wind, it comprising of certain basic. So I'm going to cover some introductory aspect, though in hurried manner, but at a glance only. And then at the end of this session, you may able to design a rooftop system. At the end of this session, I'm going to share one Excel sheet. In that, you can enter the data according to your choice. And at last, you will able to get some installations rating within your hand. So let's begin this session. So if you can talk about the solar energy, ultimately the solar energy is divided into two parts. The first part is the solar thermal. That is what we are using nowadays, application of water heater. And the second is our session, because this session is purely designed on the basis of electrical engineering perspective. So we will go for the solar PV. This is the GIF for solar thermal, left hand side, bottom corner. And if you can talk about the today's session, ultimately we'll focus on the solar PV. Now, this solar PV is not a new concept. If you can go back in the primary school days, we are having the effect known as photovoltaic effect. So the photons available with the solar is converting into the electrical energy, and ultimately we are harnessing the green power from it. The details with my email ID is shared on the screen, and you will get in the form of PPT at the end of this session also. So at any point of time, you can drop an email if you have any doubt. So let's begin the thing. So this is the brief outline of my talk. If we start with the introduction to green technology at glance, we are having some contributions in Indian grid, some photovoltaic introduction, and the basic difference between solar, photovoltaic, and the conventional PN junction, the characteristic of solar PV. Then what happens if we'll connect that solar PV to the DC load? Then we will go for the standalone photovoltaic system in the case of hybridization. Then we shall focus on the design calculations of standalone PV system. That's what I shared with you in the initial part of this session. Then we have a grid integration of single phase PV system at glance. Then I have also prepared some simulation analysis of buck and boost converter that is connected with the PV for having a practical approach. And at last, with the small prayer, we will conclude our session. So if we can start with the introduction to green technology, this figure or these figures that has been seen on your screen is very much familiar to you people. So if someone can define the renewable energy sources, so by and large, each and every source are the renewable energy sources. Say, for example, coal. Coal is renewable, but the definition of renewable sources are such a way that it could be replenished within the one human life. So coal is replenished, but we human beings are not alive for that much huge time. So this could be categorized as a non-renewable energy sources. Over here, we are talking about the green technology. So in green technology, we will go for the solar, wind, geothermal, biomass, natural gas, and in the current state of the electrical engineering, we may also focusing on the hydrogen energy by harnessing the hydrogen via hydrogen fuel cell, and in the near future, we shall charge our electrical vehicles through solar panels. So this is what the introduction of green technology at the glance, because till this time, you people have fond of literature with you, why we are harnessing renewable energy, what is the global warming. So it is the takeaway definition from you people at any point of time. If you can refer any page of Google or any other web page, I'll just focus on the technical things in this case. So these are the main sources. Over here, you may find some other new sources also. Say, for example, biomass is known to us, geothermal probably known to us, the hydrogen technology, it is most important source as far as the fuel part is concerned. In case of hydropower, number of people are not aware the hydropower are divided into three parts. These hydropowers are conventional hydrothermal or hydropower plant, the second is the mini hydro, and the third one is micro hydro. In the case of mini and micro hydro, depending upon the megawatt rating of the power plant, the output will be decided, and it can be categorized as a renewable energy sources. Then we have a new concept of net zero building. So in case of net zero building, we are having the consumption of the building through renewable energy sources. Then we have ocean energy. It is categorized into again three parts. The first is the tidal power, harnessing the tides by the position of the moon in the sky. It's a natural way of resource. Then OTEC, that is ocean thermal energy conversion. And the third is the wave energy, solar photovoltaics, that we are going to discuss. Then, depending upon the vehicles and fuel technology, we will go with the hybrid cars or hybrid electrical vehicles. And at last, it's a wind energy. So in the case of various renewable energy aspects, today I shall try to explain you people about basics of solar photovoltaics. So if you can talk about the current situation of the percentage contribution of renewable energy sources in the grid, particularly in Indian grid. So ultimately 368 gigawatt total production of the Indian grid as of 31st of January 2020. And in that case, the percentage total of the renewable energy sources are 23.4%. So we are going towards the green technology. If you can able to observe this thing in the current situation, means nowadays this data is slightly increased. This is the data of 24th April 2020. Now, you might be know that some web pages are available. So those web pages are there in the internet. I have taken this from the very famous web page, MNRE. So being as an electrical engineer or a student of electrical engineer, one must know at least about the present generation, means what is happening to the grid. So this RES term is ultimately the renewable energy sources, and we have taken this data from MNRE. It is 23.5% of the sharing from the total power. Among that, 23.5%, 60% still are coming from the wind. More, 39% is coming from the solar, and 1% are the other sources. But solar is very easy to install, and it will generate the DC energy. So it is very popular for a rooftop application, because in the urban area like Ahmedabad, Surat, and other metro cities, we shall not able to get higher wind speeds. So we are not harnessing much wind power that is available at our rooftop, because we are living in the city area. So this is one of the most important websites. If you can click on it, you will get lots of other things that is to be used in this case. Similarly, you can get all the data from the particular web page. So if you can have this thing with you, you will get the various subsidy rates. So when we talk with the experts of your institute, they share that we shall have some criteria or discussion on how much power that is to be installed at the rooftop. If I have given the right to share the screen, this is what the web page of MNRE. So you'll get the report, you can have the applications, and etc., and how the installations have been achieved. Similarly, some other important pages are there. One of the important page is this. It is nothing but the vidyutprabha.in. So whenever we are having this click on this, you will able to get the Indian map in that. And from this map, you will able to see that what is the current demand, how you can have a net metering, what is the cost of net metering. Now, here I will take some discussion on the net metering. Net metering, it's not a conventional metering. Suppose at our home, we are installing 1 or 2 kilowatt of solar photovoltaic. So instead of our meter, we shall go for the net metering, that is the bidirectional meter. So if we don't have a much load at our home, we are going to shell the power. In India, we are having 96 transactions per day. Means after having a 15-minute of time span, the data is going to be changed and it is to be recorded. And you may also go for various states. In the case of state, you will get the data. See, again, the data has been changed because right now it is 1515. From 1515 to 1516, the data has been changed and the demand has been slightly decreased. So the unit cost will be reduced from 2.81 to 2.78 if you need to feed the power. And this is what the current state demand. Shortage, if it is there, obviously Gujarat is energy surplus state, and this is our exchange rate of the particular for various power purchase agreements. So these are some important web pages that anyone can be are going to be served, and you will get the basic idea about the renewable energy sources and what the Indian grid is used to have this thing. The basic aim to share this kind of thing is to update in the knowledge, means from where we are harnessing the electrical energy, and if we are having the rooftop at our home, then how much power it should be produced and how much power we should penetrate into the grid. If you will find some time in this vacation period, you may surf the NREL, that is National Renewable Energy Laboratory. It's a very good tennis laboratory. You will get all the reports, details, papers, transactions in this, so you can upgrade yourself in the era of green technology, if at all. Now, we shall start with our basic concept of the photovoltaics, that is solar PV. When I said that this PV is not a new word for us. The photovoltaic effect says that if the light falls onto the bulk material, the material has the characteristic to generate the power. It is nothing but the photovoltaic effect. Now, this energy that we are harnessing in terms of photons. So photon is the input. So there is a myth. It might be I can say a corrected myth, but there is a myth in the mind of people that we are not getting very good efficiency. Suppose the efficiency of solar panel is 15 to 20%. It means that from the available energy.
Yes, sir.
Yes,
That's sir.
Yes, sir.
Sir, your voice is not clear.
Okay.
Cut થાય છે વચ્ચે વચ્ચે તમારો voice.
Okay. Let me check once.
I think.
Sir, now it is okay?
Yes, sir. It is okay.
Okay, sure. Okay. Shall I proceed? Okay, sir. So, when we were talking about the photovoltaic effect and the PN junction, I'm going to repeat this thing in hurried manner. What has been left due to the bad voice. Sorry for inconvenience. So, as far as photovoltaic effect is concerned, when the photons is going to be fall on the material or a bulk material, it is a tendency of the material to generate the DC electrical energy known as photovoltaics. Now, if we can take the very basics of the material science or of physics, we are having the two bands. The first band is the valence band and second band is the conduction band. And if you can way back in the 12th classes, we are having the concept of the Fermi level. Above that, if you will provide the energy via external means, then the electrons must jump from the valence band to the conduction band. Now, talking about this Fermi level, ultimately photovoltaic is nothing but the PN junction. It's a wafer of PN type. So we have a P type of material, we have N type of material, and in case of P type of material, band. So when the light will fall on the PV material, then this band will become bands. As the band will become band, that is, electron hole pairs are generated, and the electrons is going to be pumped up from the solar photovoltaic panel to the load over here. From these two sides, the circuit is open, but if you provide some electrical load, the actual current will flow. There is one more web page. It is very much important for all the engineers. Ultimately, it is a PV education. You can have your own subscription on it, and you will get the various effect and through GIF images. So if I can start this, if it has no light, this is what the majority charge carriers and minority charge carriers in PN and material respectively. This band, that's what we have discussed, is nothing but this depletion region. Now, these are the two parameters for the photovoltaic cell. The first is the VOC, that is open circuit voltage, the voltage that has been measured across the two terminals of the cell or the module. So if you can click on that, the collision takes place and more number of electrons and hole pairs are created. But as the circuit is open, we will not get any energy that is to be generated because due to the open circuit and very small field has been created. But as we have turned up into the short circuit, the electrons are going to travel from anode to cathode. That is what the common concept we are going to apply over here. So when the light will fall on the material, the band is going to be bent. This is what the concept of the PV. Now we are going to compare this PV cell with particular PN junction. So this is what the characteristic of PN junction. I'll not take more time in that because it is known to you. Externally, we are applying the DC power. Obviously, over here some load is connected. Otherwise, your external supply will be short circuited and the current will flow through diode. And this is well-known characteristic of the forward biasing of the diode. Now, over here, what happens? We need to generate a source through PV. So, in the same case, if you can compare this cell with the PN junction, the direction of this power flow will be reverse. So, it is a kind of same thing. In this case, the power flow will be reverse. So, what is the first change we observed? First change we observed that the direction of the current. Obviously, the polarity of the voltage over here remains same because ultimately it's a DC voltage. So, in the case of source, we are having the diode junction connected with the parallel PV source. And over here, what we are trying to explain is nothing but the recombination. Recombination will create the electron hole pairs and ultimately a current. So, PV has been modeled as a current source. It's a DC current source. Lots of people, lots of students have messed with the same thing. It's a current source. So whenever we are generating the current, it is in terms of the current source and it is connected with the external circuit. So if you want to plot this graph, what we did, we have just flipped this curve. Why? Because we are changing the y-axis on the negative side. So this is a small video from which how we can flip the curve. This is conventional PN junction.
Sir, slide change
And then
નથી
we
થતી.
flip it.
I think slide hang થઈ ગઈ છે.
Okay. Now it is okay?
No sir, it is the slide is photovoltaic effect and PN junction. Now it is changed to the PN junction PV cell.
Yes sir, I am on this only.
Okay sir.
So I am trying to repeat the same thing. In case of PN junction and PV cell, ultimately we are having the external circuit. It has been fed some DC source to the diode. At that time, we have known to this characteristic. That is what we call as a forward bias characteristic. Similarly, over here we need to generate the electrical energy. So the direction of the current is reverse. As the direction of the current will be reverse, we need to flip this IV curve into this first quadrant. So how it is flipped? So this is how the curve has been flipped. It will go down and then we will change the axis, because now we are in the generating region. So it is very easy from this figure that the direction of the current is reverse and the characteristic has been flipped. This pure, neatly shaped oval curve is the ideal diode characteristic, and this curve is known as the IV curve. In this case, we are having anode and cathode, and we are assuming that current is flowing through anode and cathode. Over here, if you can change the terminal, you will get the positive voltage also. So this is the basic difference between PN junction and the PV cell. Now, how we can convert that cell into module, module into array, array into string, battery. If it's a first semester theory concept of the series and parallel connected DC system, if somebody can say that what is the application of series connected DC system, then anybody will love to answer. But if you can talk about the parallel applications of DC system, we are happy to share the examples of various loads, but they all are working on AC. So if you can take an example of parallel connected DC system, then you can take a load which has some current demand. Say for example, 2 ampere is the current demand at 12 volt, but one battery should share 12 volt and maximum current is 1 ampere. So we need to accommodate one more battery in parallel to that battery. So our current demand will be double. Likewise, all the cells are connected in series for the preparation of either module or panel. Usually, the panel is more cell compared to the module, but more or less the module and panel are the similar words. Similarly, in the case of panel, all the cells are connected in series, and you will get the higher amount of voltage at the output of the panel, and depending upon the selection of the inverter, we will decide how we can connect certain panel into series and parallel combination. So if we can talk about the single cell, generally the cell rating is of 3 watt and 0.5 volt DC. The cell thickness is 100 to 500 micrometer with the thickness of about 0.3 mm, and the surface area is 100 centimeter square to 225 centimeter square. Talking about the module, number of cells for the experimental purpose, we can have a module, and number of modules we are going to accommodate as a solar panel. Now, the basic question is how the solar panel is oriented. the first answer, what we will get, those who are working in the field of solar, sir, it is in the direction of the sun. Obviously, it is very correct answer. It is in the direction of the sun, but the direction of the sun is not fixed. It is going to be vary. It is not going to be vary for all the time, but it is going to be vary with the change in climatic condition also. Say, for example, season. In the case of winter, we are having the slant radiation. In the case of summer, that's what we are facing nowadays, exactly perpendicular with some angle. That is nothing but the delta declination angle. That thing is already done in the school geography classes. If you can go back in the school, you will be recall this concept. But nevertheless, the point is this: how the solar panel is oriented. Ultimately, the panel is oriented for India. It is oriented towards true south because we are in the northern hemisphere. So if I'm standing by facing true south of my face, the sun will never go on the back side. So the panels are oriented towards south. Similarly, in the southern hemisphere, they are oriented towards the north. And the thing which is not written over here is at the equator, it is a flat. So that is how the panels are oriented. Now we'll talk about the important concept of the photovoltaics IV curve under standard test condition. The standard test condition, abbreviated as STC, which is defined as insolation, that is radiation of 1000 watt per meter square, 25 degrees centigrade temperature, and 1.5 air mass. This is known as the standard test condition. Sometimes it is standard temperature condition, but the correct word is the standard test condition. So if you can have a panel with you and you are going to open it, taking terminal outside, and you will connect the multimeter over here, putting the knob into voltmeter on DC side, you will get the open circuit voltage at that radiation, because during daytime, the radiation is not fixed. Similarly, the second concept is the short circuit. In the case of short circuit, over here, the ISC will be there. So we are short circuiting the two terminals, plus and minus of the PV panel via ammeter. Again, keeping our ammeter into DC mode, we will get the short circuit current. And if you connect a significant amount of the load, then the load will draw the power depending upon the capacity of the load. So if you want to plot this curve, either you can start with VOC or you can start with ISC. Suppose I will start with the VOC. Then we are going to cut out the resistance, and ultimately we are going to bypass the resistance, and I will get the ISC. At ISC, the power, this is DC power, V into I. The current is maximum, voltage is 0. So you will get the power equals to 0. So the characteristic will start from 0. This characteristic PV. And ultimately at VOC, your current is 0. Then again your characteristic will end at 0. And this characteristic, upper one, is known as the PV, power versus voltage characteristic of photovoltaic. And obviously, at the some point of time or a unique point at the particular radiation, we will try to harness a maximum power point where we will get the maximum power from this solar panel. Number of students are known to the maximum power transfer theorem. It is the same point where the RTH equals to RL. But as the God will vary the radiation, obviously this curve will be highly changed or modified with the change in the radiation and the temperature level of the Earth. So let's talk about a particular STC ratings of one of the panel. I'll not discuss whole, but you will get the idea of the panel rating. Indian weather is very good for the multicrystalline and polycrystalline silicon material. So if you can talk about the Kyocera panel, it is a multicrystalline module, 36 cells. Peak power or DC power at STC is 120. the voltage at Pmax is 16.9, rated current is 7.1 ampere, open circuit voltage is 21.5 volt. Similarly, short circuit current is 7.45 ampere. So if we are maintaining this condition and we are short circuiting this panel, we will able to get the value of 7.45. And at last, with some mechanical dimensions, the module efficiency is 12.9%. Likewise, we are having the other modules also on the screen. So there are certain light intensity in general terms. So this table shows about the 1 sun, 2.2 sun. In 1 sun, we are having the maximum radiation, and if you can cut down the radiation level, it can be technically speaking in terms of 1 sun, 0.8, 0.6, 0.4, and 0.2 respectively. In the according of sun performance, the incident radiation or incident irradiation is going to be changed. With the lack of timing, I am not going to share this data sheet. I will again share in the PPT mode. How we can have the formation of cell to module and array? Suppose if each cell will generate the 0.6 volt and all the cells are connected in series, in the addition of that, what you will get? This you will get as an open circuit voltage by adding the 36 cells. Similarly, whenever you will reach at the 36 cells, these 36 cells will become a module. Then, if number of modules are connected in series, you will get the higher voltages in terms of open circuit voltage and voltage at maximum power, that is VMPP voltage. So as the voltage is going to be increased, panels are said to be connected in series. Likewise, they are connected in the parallel if we need the higher current. Now, if you can plot this curve in particular way to find out the efficiency, so the biggest rectangle that should be cut out from the MPP point to various ISC and VOC axis, that is current and voltage axis, you will get one factor known as the fill factor. This is the ratio of power at maximum power point, that is multiplication of VR into IR, that is available from the data sheet, divided by VOC into ISC. So over here, if you multiply this, you will get the fill factor. Now, this slide showing the effect of the temperature on the IV curve. Over here, the radiation is 1000 watt per meter square or 100 milliwatt per centimeter square. And by keeping this radiation constant, we are changing the temperature of the photovoltaic module from 25 degrees centigrade to 50 degrees centigrade and 50 degrees centigrade to 75 degrees centigrade. So at that time, in the case of PV module voltage or PV cell voltage, the difference in the per unit has been observed. So we are not going to conclude from this slide. We will conclude in the next slide. Similarly, at 25 degrees centigrade, we are changing the radiation. So in this case, the 100 watt per meter square, 750 watt per meter square, and 500 watt per meter square, the application of the radiation on the current has been observed. It means that the radiation will highly affect the short circuit current and hence maximum power point current, and the temperature will affect the open circuit voltage by and large. So when we are discussing about the open circuit voltage and short circuit current, at that time we are having the IV and PV curve with the change in radiation and the change in temperature, because in day-to-day life we are facing change in both the cases, that is radiation and the temperature. Now, as far as IV curve is concerned, we are having the three zones. The first zone, that is the first rectangle in this case, it is the constant current zone or current source zone. The module has been operating in the current source zone, then you will get almost constant current. Then we are having the power source zone, and then we are having the voltage source zone. So we'll try to operate our load at this point. It is nothing but the power source zone. We'll try to operate it. Suppose if you want to connect the resistance, ultimately at the first point, if you start by inserting the full resistance, you will get the open circuit voltage. If you cut out the resistance, you will get the short circuit current. So you are going to operate in all the three zones. And this is what the comparison of the same curve, that's what I tried to describe in the previous slides in zone wise. There is also one rectangle, it has been seen in the outer side of the PV module. As the power generated by this rectangle is more than the rated power of the module, we have considered inner rectangle at MPP point to compute the efficiency of the PV module. So we have taken this example of Kyocera intentionally. This is what the impact of the first slide, change in temperature on the open circuit voltage of the module with data. Previously it was per unit, and over here in the second case where the cursor is there, hope you have seen this cursor, is at 25 degrees centigrade constant, and we are going to vary this radiation particularly. So as we are going to vary the radiation, the short circuit current is going to be changed. There are some more resistance that is to be incorporated in the solar PV module. These resistance are resistance offered by the material itself. The first resistance is the shunt resistance, and the second resistance is the series resistance. It means that if you can open up the PV cell or PV module, the resistance will not come out from the material, but it is a tendency of the material to oppose the flow of the current. Say for example, if you have a shunt resistance, then it is due to some manufacturing defect, poor cell, particularly at low light level, there will be less generated current. So if my shunt resistance is low, then that resistance is connected in parallel with the diode. Because it is shunt, it will increase the power loss of the cell or the module. And similarly, in the series resistance, it's the movement of the current through emitter to base. So ultimately, it will reduce the fill factor. And it is also the contact resistance between metal contact and the silicon itself. Because in the PV module, if you have seen, you will be able to know some silver color buses. It is nothing but the metal contact, and it is the end of a particular cell or a particular part of the cell. And accordingly, the series resistance will be changed. I also mentioned some important links of the ebook. You may easily explore this if you want. Now we'll talk about the parallel or shunt resistance on the IV curve of PV. Means if you are having certain boundaries of parallel resistance or a shunt resistance, then how it is affected with the curve. So for a cell particularly have losses of less than 1% due to its parallel resistance, Rp is greater than 100 VOC upon ISC. And if you apply this much reduction in the IV curve, you will get this much reduction in the IV curve you will get from the standard IV curve. So if you can take an example of 60 watt panel, by considering the 60 watt peak power, 17.1 open circuit voltage, 3.5 ampere short circuit current, 58 watt is the net power output with fill factor of more than 80%, 3.8 ampere again short circuit current, I beg my pardon, 17.1 volt is the voltage at MPP, 3.5 ampere is the current at MPP, that is the multiplication, you will get the 58 watt, and 3.8 ampere is the short circuit current, and 21.1 volt is the open circuit voltage. Obviously, 21 volt is higher compared to 17, so 21.1 is the VOC, and in this case, our RP is greater than 555.26 ohm. So there is less possibility to divert the current through RP. For a particular large cell, it might be a 7 ampere and VOC might be 0.6 volt, which says that the parallel resistance should be greater than or about 9 ohm, because it can be applicable for cell, for module, for array, for string, and for entire power plant. Talking about the series resistance, again it is 1% due to this series resistance. That is the voltage drop that has been observed, and this is what the series resistance as small as possible. So this was reduction in the curve you might be observed, and similarly we'll get the particular large cell which is less than 0.0009 ohm. If you have an actual impact by considering some random value from 0.05 ohm, that is series resistance, and 1 ohm of parallel resistance, this much reduction in the curve. See, this is the reduction in the curve. And if some tall buildings are existing next to PV module, then there is a shading on the PV module, then this constant is again increased and your curve will go down. So there are lots of solutions by incorporating the bypass and blocking diodes with the module. That is to be there. So this is our final equation of light generating photovoltaic system through light. If IPV is the photovoltaic output current, the IPH is the photocurrent, IRS, particularly current due to reverse saturation in ampere, it is usually into 10⁻⁻12 ampere, and with some other constant. Over here, we have when the light will fall on the material, it will generate the current over here. It's a single diode model of the PV cell or a PV module. This is our RSH, that is parallel or shunt resistance. This is our RSC, series resistance, and ultimately we'll get the IPV from here and we'll get the voltage. If you can simplify this equation, our current is proportional to the voltage with ln. Current proportional to ln of voltage. It also proves that with the high change in current, there is less change in voltage. And we have also checked that with the change in radiation, there is highly impact in the current, and with the change in temperature, there is high impact in the voltage. Now, we'll talk about the current and voltage curves for particularly electrical load, and that is nothing but the DC load. So if you can take any example of DC load, you can connect that DC load with the panel. Say, for example, fan. We have enjoyed the fan by wearing a caps in our primary school days or our childhood days, where it will vary with any speed. That's what we don't know at that time what is the speed also at that time. So we need a converters in between as an interfacing medium, but it will operate randomly. So if you can take an example of DC load, the first is the resistive load. So if you connect the resistive load with the PV panel, then the first concept one must able to know that is the operating point. So this is the operating point. By visually, anyone can check what is operating point, but it is a point at which the IV curve of PV, IV curve of the PV is interfacing the IV curve of the load. So now you can think about the curve, means IV curve of resistance. Obviously, it is the straight line, and it could be modeled using I equals to 1 by R into V. So as I mentioned that if you increase the R, you will reach at VOC. If you will decrease the R, you will reach at the ISC. So likewise, this operating point will vary. In this diagram, we are having the various slopes because we will try to keep the radiation and the temperature fixed. But if the climatic condition will change, we are having the multiple operating points for the fixed resistance load, and those maximum power points are far away, means we are not getting the efficiency at the higher level or larger level, and accordingly the power output is going to be vary. So we need to incorporate certain algorithm, that is what we call MPPT. The second is much interesting example of the DC motor IV curve. This is what the IV curve of the conventional DC motor. Now we are going to establish the relationship between this curve of the DC motor and the IV curve of the PV module at different radiation by taking the operating point considerations. So when we will discuss, this is what the superimposing of the DC motor curve on the various IV curve at the different radiation. Now, if one can use this motor, that is permanent magnet DC motor, for water pumping application connected with the PV. So the problem of the curve is very severe. The main problem is that during startup current, it requires the very high radiation for 400 watt per meter square, but it can run at 200 watt per meter square. So if we want to turn up our DC motor during early morning or late evening for the farming application, then we would not able to operate. So certain devices are known as linear current booster. It will convert the high current low voltage or a low current high voltage to low voltage high current. So at least you will get sufficient amount of voltage that is to be developed, though the motor will rotate in very slow speed, though we are getting a little amount of water during early morning and the late evening. And this is what I explained, and this is what the connection of the linear current booster. The low current high voltage supply is converting into high current low voltage supply. And the third component is nothing but the battery, that is IV characteristic of the battery. If you are not considering the internal resistance, it could be a straight line at some voltage. Sorry. And if you are considering the resistance, depending upon the charging and discharging condition, the IV curve will be vary. Now we'll talk about the standalone solar PV system and its component. Talking about the various standalone solar system, nowadays we are not having the single source. We are having the multiple source, means more than one renewable energy source. So if we can use the PV connected with the load, ultimately now our load is AC in nature, that is alternating in nature, because it will consume a power at constant 230 volt, and the current rating is depending upon the loading condition. So in that case, there might be a kind of this system where photovoltaic panel, charge controller, inverter, and the load. So if you can talk about the typical system or a home system, we are having the PV generator. Why it is hybrid? Because the battery is used as a backup. Then through charge controller, we can run our DC loads, that is operated DC lamps, radio, television, etc. If we can talk about the double or hybrid sources, we may also go for multiple PV modules. We are having the different islanding schemes. We can use the diesel generator. We can have various wind options or a conventional diesel power plant options as a backup. And we can have turn on and turn off the load. And it is obviously the demand of our bottlenecks. If you need to explore further, the video has been made depending upon the various hybrid energy schemes only on the renewable energy system and its design. Now we'll back to the main concept of the standalone photovoltaic system. It is nothing but the calculations of the balanced PV system. Over here, one Excel has been made from first to sixth instruction. It is very easy and it is readable to all. You need to have some input. You can input some data. Suppose one load of a residential load. What was the loading condition? We cannot say accurately because it is going to be vary. Then how many loads are there? Say for example, fan, tube light, refrigerator. I can add over here pump. That is water pump. Suppose pump is of 500 watt. One number of unit. It will operate for 15 minutes per day. So we will get the total power. That is what we are consuming on daily basis. And that's what we need. So in step 1, any user can enter the value in this sheet. So you're able to get the total wattage and total energy. Our next component is the charge controller selection and the inverter capacity. This 990 has been come up over here. As the inverter is static element, we are assuming the efficiency of the inverter as a 96%. In this sheet, the upper and lower cap has been also mentioned with some field practice experience. But some inverters at constant loading condition may give above 97%. So if you will put this, you will get this much VA rating. You may turn on this or converting this value into nearest value of the market availability of the inverter. And similarly, yes, sir.
Sir, I think slide is hanged out.
Sorry, sir. Now, sir, a solar PV system slide is
no, sir. Standalone PV system.
It has been seen, na?
Yes.
Now, any Excel sheet is there?
No, sir, not.
One Excel sheet is opening via hyperlink.
Sir, you can share the screen of the Excel sheet.
Okay, sir. Sir, can I press stop sharing?
Yes, sir, no problem. Sorry for the technical glitch. I request Ravindra Desai, sir. In between, we are going to share our feedback link, and then after we again come. So. Sorry for the interrupt. Due to the network problem, sir is left from the channel. Sir is going to connect again. Yes, sir.
Now
You are
the
visible.
screen has been shared. Is it visible now?
Yes, sir.
Okay. Sorry
Screen
for
is
inconvenience.
sir, but screen is blank. Okay, it is visible completely.
Okay. Sir, one request is that when I will turn on the PPT again, please guide me.
Okay, sir. No.
So, sorry guys for inconvenience. Now the thing is that we can enter some data. Suppose in any house we are having a fan, tube light, refrigerator. Suppose I can go for pump which comprising of 500 watt. Then we are having one number of pump at our home and 0.25, that is operating hours, 15 to 20 minutes we can operate the pump. So accordingly, the wattage has been calculated, and with the change in wattage rating, over here total watts and energy is going to be changed. Over here, this total wattage are AC wattage. Particularly, we require inverter. So this wattage what we are calculating over here are the AC voltage. But over here, power equals to voltage into current. And in the DC system, particularly at our home, we can have a DC load or a AC load, more or less at the unity power factor. So we will go for the having 96% of the efficiency of the inverter. That's what we can assume. And we are having the KVA capacity as per the load requirement. Similarly, we can do it for the energy calculation. Mind well, for the good design, ultimately we will go for same efficiency in the case of energy as well as the power output. Now second stage. In second stage 2B, we are having solar charge controller selection. So we are having some watt hour and the voltage is there with us. Now, according to the battery rating or charge controller selection in photovoltaic system which is available in this world, we are having 12 volt, 24 volt and 48 volt available in the field. However, in the laboratory, you may find above 48 volt also. So from that, you will get the maximum DC current. Then we will start with the battery capacity. We are having this 3068 over here, whatever, and we have assumed system voltage over here, that is 24. If you can change this thing, the entire design is going to be changed. I'll keep it 24 only. This is our battery capacity, and then we can assume the depth of discharge. Now you can check your mobile currently. Suppose it is 70% charge. Then it is state of charge, that is 70%. Over here, for assuming 70% depth of discharge, meaning only you can use 70% of the stored energy. It means that if I have an example of 100 chocolates, I can use only 70 chocolates. Thus 30 has been escaped. So the first question is, why this much low DOD? So we are assuming the worst data for a best design. Anyhow, you can assume 90 also, 95 also. And this could be assumed 70 in this case, and according to that, your actual ampere hour will be there. This ampere hour is of battery. Obviously, in market, 183 ampere battery is not available, but nearest value is 200 Ah you can take. Then we'll go with the SPV sizing. First, we'll go with the energy calculation. We are considering the 95%. Again, the battery static element will get the 3229 energy from SPV. We are assuming only 4.5 hours of the daily sunlight, where we'll have effective power output. Again, there is a cap over here. You may assume 6 hours, 7 hours, depending upon that. your SPV module voltage will be changed. So this is 718. So we are designing a 800 watt system. According to that, you will set the wiring depending upon the wattage and voltage. So your current rating, and this voltage rating, this is a DC current rating. Depending upon current, you will select the gauge of the wire, that is SWG, standard wire gauge sheet is available. And we have already calculated the alternating current of wattage capacity. Obviously, it's a single phase system at our home. The current would be computed from the power upon voltage. So 990 by 230 is 4.30 in this case. So we can approximate this value at 4.3. And similarly, you will get the current and the power both. So if you can have this data with you, you will get all the things, whatever you want in the sheet. I beg my pardon, it is automatically changed. It is 4.5, and you will get the power output as a 4.5 ampere and 230 volt. And whenever you are having this data with you, you will design your own photovoltaic energy system from your side. Now, sir, I need your help. I need to share my screen.
Okay, sir. Okay, sir. No problem.
Hello?
Yes, sir.
Hello, am I audible?
Yes, sir. Clearly.
Hello?
Yes, sir. You are audible. Hello.
Now I guess the screen has been shared. Hello? Am I audible, sir?
Yes, sir. You are audible, but screen is not displayed.
Now it is in PPT form. Is it there?
No, sir. You have to click on share screen.
Yes, sir, I have clicked. Just a minute, sir. Again, I am doing the same thing.
Okay.
Stop screen. Share screen. Share. Now, sir.
No, sir. Screen is not there.
I have shared the same.
Hello. Due to technical glitch, we are not able to connect with sir. But I want to say that RNGPIT has the various types of laboratory in our college, like the solar lab, tinkering laboratory, assistant electrician laboratory, automation laboratory, food processing laboratory. So whatever you study in this video about the solar panel as well as the solar cell structure, all types of equipments are there in our college at the solar laboratory. So if anyone want to see the laboratory and take a real look of the components, then they are feel free to contact us. We have all the laboratories. We have other tinkering laboratories as well as the E-Yantra laboratory, which is with the collaboration of the IIT Bombay. So if any participant interested in that type of laboratory to use their laboratories, they are feel free to contact our college. Again, automation. Nowadays, the technology is using the PLC. Okay? So how to run the PLC and how to program the PLC. We have the separate lab of the PLC in which different 8 to 10 companies PLC are there. So you can explore the PLC of the different companies as well as taught the how to program the PLC. Okay. So there are the various laboratories in our college. Another laboratory is like the food processing laboratory. Okay. Then boiler laboratory. Everything is there at our college. So I request all of you to once visit the college and the laboratories to see the different equipments. Okay, I think sir is with us again. Hello, Ravindra sir. Okay. Ravindra sir, please give some idea about the solar technology recently.
See, regarding about the solar technology, today we arrange such a renewable energy sources. Based on that, there is mainly two types of the sources. Rightly, we are using into the India mostly solar as well as the wind power system. Today only we are focusing on the solar photovoltaic system, which is based on the sunlight which is directly fall on the solar panel, and that solar panel which is generated that electricity that will be helpful for the save the another aspect also. We can save that particular energy, we can store, and also we can feed to the grid also. So the main thing is to how to design the solar energy, how to integrate with the grid. These are the basic fundamental concept regarding this webinar also today. As well as in our institute, RNGPIT Institute of Technology, Bardoli, having a solar lab also, where the numbers of experiments which are also available. We set up the different sessions for that, so that the student enroll and they can get the experience, and as well as they can do the practicals on the different solar equipment also.
Us again. Okay.
Hello.
Sir.
Am I audible?
Yes, sir. You are completely audible.
Okay. Shall I proceed from where I stopped?
Okay,
Time
sir. No problem. Sir, I think 5 minutes.
Okay, I just wanted to wrap up the things.
Okay.
Okay. Now our next section is the grid integration of the single phase PV system. Over here, at the grid integration point, we need to pump up the active power. So what we will take from the grid side, from the single phase system, we are taking the sample of the voltage and current. It has been given to the alpha, beta to DQ component. Suppose we will take the beta component first. Then through phase shifter block, we are converting into alpha, and we are having a closed loop through PI controller, and we will generate the row. I'm going to share this PPT also. It has been clubbed with the same PPT, and you can explore the more from this link, which is given as under. So if you can compare this VQ axis, that is equals to 0. So we are feeding only active power into the grid. Similarly, we will generate the row by converting this DQ to alpha beta axis coordinates. And accordingly, you will generate the ID and IQ, and that has been compared with the reference current in voltage taken in by keeping the sample of VT and IT from the photovoltaic module through MPPT controller we are generating the star quantity. Over here, it is the 0, and we are generating the reference V beta, and we are having the gate drive circuit, and we are targeting the pulses of the single phase inverter. This entire system could be running in the closed loop. Now we are having some simulations in the PC software. This is the IV and PV curve of the solar module. And we are having the boost converter calculations with given MPPT algorithm in the software, even in MATLAB also. Over here, we are having some change in radiation by keeping temperature constant. And over here, the boost converter has been simulated for constant DC load at STC, and the resistance is of 20 ohm. This is the case 1. And over here, the boosting of the voltage has been observed. For 15 ohm, again, we will increase the load by decreasing the resistance. Again, we will have a boosting effect. And this second graph is what the Pmax, that is maximum power, and P naught. Then the watt solar shows the power drawn by the system. And this is the pulse of the switch. Again, at 10 ohm, again at 5 ohm, and now we will check the pulse has been removed. So at this condition, there is no boosting effect, but still we are getting the close efficiency to the generated power. This is, guys, this is our maximum power transfer theorem. Now we can have a variable radiation and temperature, and certain cases have been discussed. Now if you can remove the switch, so this is the comparison without MPPT, and this is with MPPT. I'm going to repeat it. This is without MPPT. You can check the Pmax and P0 pulse, and this is VMPPT. Now we are going to conclude and summing up this thing by having one video with us, so we'll be able to know that which things we are facing nowadays. So after 10 years, the same fellow came in the platform of TED, and the link is already there. So as far as the conclusion and summing up, if you need to install a solar PV panel at your rooftop, then this is what the price per kilowatt. and it is available in MNRE website. But the beneficiary should have at least 100 square feet shadow-free area per kilowatt capacity of the solar system on the rooftop. These are the various quotations as of now. These are the other subsidies that has been given by the government, but due to this pragmatic, it has been stopped for a while, and we will hope it will be recovered soon. So let's pray for the humanity. And with this, I'm going to conclude my lecture with one message. Because one more thing, that is energy conservation. So thank you very much for your time and patience listening. I'm very much thankful to all the coordinators and the institute for giving me an opportunity in this crisis in the world through online platform. Thank you very much.
Thank you very much, Siddharth sir. Sir, we have some questions from the participants.
Please. Okay, sir.
The question is, explain from the basics. In the next session, include the brief about the grid integration and what about the frequency mismatch. So, sir, can you say something about the frequency mismatch?
Usually what happens, as far as frequency mismatch is concerned, this thing could be highly pronounced for the wind integrations. But in case of small frequency mismatch, what happens? The inverter works at the constant frequency or the band of the frequency, because regulatory board in India, we are having 49.5 to 50.5. So say, for example, if there is a central inverter where the frequency will be depending upon the inverter switching frequency, but the PV is not working. So at that time, to maintain the frequency, certain amount of power has been shedded in terms of the generator, and the frequency has been matched. Now, when we are talking about the frequency mismatch, in that case, we should study in detail about a three-phase grid integration, because in single-phase grid integration, we are having an inverter which is smart and hybrid in nature. So if your frequency will mismatch, it will disconnect the source from the system, and our solar home will be enlightened with the conventional grid automatically due to the capability of the inverter.
Okay. Sir, another question is that the query, is there any related value of heat absorb of solar panel? Like maybe also damage in very high heat absorption sometimes or not?
It happens usually due to the unawareness of not cleaning the modules frequently, due to the bird droppings, due to the improper placement of the cell, due to the constant shedding on the photovoltaic module. It might be happen, but people are recommended to clean the module at least once in a day. Say, for example, I'll take one practical aspect. One company known as Sukam, it's an inverter company. They are start manufacturing the modules. And with my students, we have installed one power plant at one of the rooftop. So they recommended that. Why we are doing the same? Because people are calling because they are not cleaning the modules and inverter is not working. Obviously, inverter will work on the specific voltage window. If the voltage will go down, obviously the inverter will not work. In technical language, in power electronics language, we can call it as a DC link voltage.
Okay. And sir, last question is what is the effect of panel angle on efficiency of panel per degree?
Okay. There are different values of the angle. It is known as beta. That is tilt angle. Usually, what we have discussed in that slide is we are oriented towards south because we are in the northern hemisphere. But the tilt angle is always equals to angle of latitude. However, some degree of freedom is given for small power plant. Otherwise, the angle is fixed. That is angle of latitude. However, in certain locations, if degree of freedom will not be taken, we will go for mechanical maximum power point tracking. So your panel will oscillate like a sunflower.
Okay.
So it is always oriented towards the sun's direction.
Okay. Sir, one or two more questions are there. Will you allow?
Please. Yes, sir.
Sir, the question is, what is difference between radiative and nighttime PV?
Okay, in case of radiative PV, usually during night time, what happens is RS and RSH, it will take the power from the grid because it's a bulky material. So at night time, there is a protection, simple diode is there. So during daytime, in the radiative PV, we are having only 0.7 volt voltage drop loss due to that diode. But during night time, that blocking diode, it acts as a block, because it acts as a reverse bias due to reverse power flow of the current.
Okay.
So the material has tendency to face the current from the grid, and it will block that.
And sir, last question is, government is planning to install solar power plant in Ladakh. So will it be efficient as temperature in concern?
Yes, it is. Means in Ladakh, particularly, the temperature variation is very low, and that what advantages we will take, because as we have taken theoretically only, in this case, the main impact on the voltage is due to temperature. So in Ladakh, the temperature variation is less compared to what we are facing in Gujarat. So we are in the era of the constant voltage system. So if we can maintain that voltage, then the output is awesome in our case. In addition to that, right now we are having two main modules, that is polycrystalline and monocrystalline. People are also harnessing from the silicon amorphous. In that case, they will reduce the short circuit current and increasing the open circuit voltage, keeping power output constant. So in such situation like Ladakh, where the radiation is also have a big issue, at that time, we are having the less change in the short circuit current because the overall value of the current is very less. So we can harness the effective power output from the installed PV. And we are having a 1 megawatt power plant next to our institute. And we are having that 1 megawatt peak power capacity. We are not getting 1 megawatt every day. It is depending upon the climatic conditions.
And
installed capacity.
It's an installed capacity, peak power. Please,
yes,
sir.
Yes, sir. Are solar panels affected due to heavy rain from anyway?
Yes, due to reduction in radiation, there is slight change in the short circuit current. We have taken a case study of the Gujarat High Court. In the month of June, the top floor air conditions are working from the installed PV capacity. So it is also depending upon the loading condition at that time.
Thank you very much, sir, for our valuable guidance. Now I request Ravindra sir for the vote of thanks of the sir.
Thank you very much, sir. It was very informative session. I hope this webinar will help to our students. And thank you very much for giving your valuable time with us. Thank you very much.
Thank you. Thank you.
Thank you, sir. Thank you, sir, for very micro knowledge regarding PV module, as well as load calculation and very interactive session. Thank you very much to our alumni student for making this session interactive, question answer.
Okay.
Thank you, sir.
Thank you, sir.
Goodbye and good evening.
Goodbye, good evening. Thank you very much.